Maybe the biggest message from this presentation is this line here. Now JAXA has a organization by the name Space Exploration Center, JSEC, and these guys will be responsible for the exploration program, including Martian program like MMX. So, and this, all the slides were prepared by these people. I'm a part of it. So this is a big, the biggest picture of what this center is about. They are in charge of ISS as well, but they also have the future program for the moon exploration as well as for the Martian exploration. Now, then I would like to focus on the lunar part in this talk. So in the past, we had Kaguya spacecraft orbiting around the moon, and it's on the experience and on the knowledge of this through this mission that all the basis of our lunar program is in. And yeah, so then into the future, what's happening now? What's going to happen next? It will be these two missions. These are the CubeSat on board, piggybacking onto the SLS-1. So Omotenashi is like a semi-hard landing mission through this kind of a system. It's a CubeSat, but it has this complicated architecture, and then eventually it will try to have an element on the surface of the moon. But as you can tell, because of the limited resources, it's going to be a real, semi-hard landing, but almost hard landing. But anyway, this is like a, technology demonstration of what you can do with this kind of limited resources. Maybe if it turns out to be useful, maybe into the future, when more and more people are willing to deliver surface element to the moon, this can be the lowest cost way of doing so, but we'll have to see. And another mission, another CubeSat mission is by the name Equuleus, and that's really like, flying from Earth and how do you control your trajectory so that you can utilize the moon gravity assist to change the gravity even more. So again, this is like, how much flexibility in your orbit design you can gain with this limited resources. This is another technology demonstration. And then beyond, we have a bigger mission, a slightly bigger mission by the name SLIM. This is to demonstrate the pinpoint landing technology. And what I mean by pinpoint landing is the landing accuracy up to 100 meters. And it's going to land next to a rock, which is interesting, and then make a multi-band camera observation of the rock so that you can have a microscopic observation of the rock you're interested in. And in order to do so, you have to land next to the rock of your favorite. So that's the science, but it's mostly a technology demonstration. You might be wondering why a spacecraft is lying on the surface. I'll come back to that later. And then after SLIM, utilizing the pinpoint technology that we gained in this mission, we have a plan to go to the polar region, which really requires pinpoint landing technology. And then, of course, the driver behind is the water is the resources, which is the water in the case of the moon. And then in this mission, we try to collaborate with India, who has just launched their lunar landing mission this week. Yeah, and this is a big. This is a bigger mission, but this is not a real big mission. But anyway, let me try to explain what SLIM is about. Did I give you the size? Yeah, the spacecraft is only 200 kilograms, so it's relatively small. But given with that limited resources, we tried to make a pinpoint landing, because then that can be a way of delivering your element to the surface of the moon in a rather low cost way. And with pinpoint landing, you can get to the point you want to get to and then make some nice science. And another feature of this SLIM is this attitude after landing. It's not standing, it's kind of lying on the surface. This was the solution that came because we only have a limited resources available for this mission. But like, well, how do I call this? It's like, but then, well, the driver was the limited resources. But once we designed this mission, we came to the idea that this might be a good way for landing on a steeper slope. If you try to land, if you try to stand after landing, steeper slope is not a nice place to live. But if you can accept this kind of attitude after landing by installing your instrument, knowing that you will land in this way, maybe getting to the steeper slope maybe this is the solution to land on a steeper slope. And again, this can be realized even with the limited resources. So once we make this successful in a couple of years, that can open up a new door to get to the surface of a gravitational body. And this is the bigger mission coming after SLIM, utilizing the pinpoint technology gained by the previous mission. How do we work with Indians are described in this way: launcher by us, and then the landing system by the Indians, and then the rover by us. Rover will have several science instruments, and then now that it's almost like the style we gained by running the MMX mission, but we are thinking about having maybe more than half of the key instrument on board the rover to be coming from our international partners. So I think there would be an international consortium for the rover instrument. So I hope you stay tuned for this mission. Beyond that polar landing mission, of course, the gateway is coming up, and there's an idea of participating, contributing to the gateway through providing this technology for the habitation, as well as providing a logistic support to this mission by upgrading the HTV vehicle we already have. But this transport process, transport element, is useful not only from transport from Earth to the gateway, but it can deliver some small satellites from gateway to the lunar surface. So again, through this contribution, we may be able to create more opportunities for the scientists who is interested in having a CubeSat orbiting around the moon, or making a small element having access to the surface of the moon. But again, that's an idea that's been explored by us right now. Then about the gateway itself, there has been a workshop asking scientists, how would you utilize a gateway? And the people from space science were there showing their interest, and astrobiology-related people are also interested. Microgravity community, as well as the space gravitational and radiation biology community, they're really interested in gateway as well. And especially these people think that ISS is not a real outer space environment, but performing more or less similar experiment that they have been doing on ISS, but on gateway, will really gives us the fundamental knowledge about what happens if we are to explore, if we are to expand into the outer space. So that's what these committee people are thinking. And yet into the future, when we are to explore fully the surface of the moon, that has a closer relevance to what people are doing on the ground, on Earth. So right now, when you say space mission, it's a mission that's flying in space, and relevance to what the business people do on the ground is kind of not that direct. But once you think about doing something on the surface of the moon, people like a construction company, people like these people, they think there's a closer connection to what they do now for the business that bring money to them. So in that sense, this organization within JAXA, Space Exploration Innovation Hub Center, has been kind of successful. Here, we work, JAXA and the industry work on the same research theme. That has a dual purpose objectives, space and then on ground. We work on the same theme, same thing, but there's a spin-off to space, and there's a spin-off to the application on the ground. And the space element, we JAXA grab and then try to use it for expanding our activity in space, like the on the lunar surface. But for the terrestrial application, it's for the industry people to grab, and then with that they can develop a new business on ground. So it's a win-win situation. We work on the same thing, but our dreams are different. But I think that's okay. That's the key in making this center to work in a very successful way. And then, yeah, like for this case, like a construction machine on the lunar surface, it has to be lightweight. It has to be lightweight. But if it's lightweight, it's more fuel efficient, so that's good for ground operation, application as well. So it's this kind of style that this collaboration in this innovation hub center is working. And yet into the future, Toyota is interested in providing a human pressurized rover, a big one, a size of you can see how big it is. No. I don't know. Well, no. But their interest is that, Toyota is really moving towards a fuel cell vehicle, and they think that they can use this technology. Toyota is a big company, so they're interested in benefiting the humanity, of course. I should have said it at the beginning. And then they think they are moving towards the fuel cell technology, fuel cell vehicles on Earth. So why don't they try to apply that technology to the big rover, the huge rover on the surface of the moon? So we have agreed to work with them. JAXA has agreed to work with them in March this year. And then the target for this rover to be on the surface of the moon is like 2029. So with that, I'd like to close my talk. I just want to mention that, we're happy to work with the international partners. I think that's the core message of this presentation. Thank you very much.
Thanks so much, Masaki. David.
Masaki, JAXA had been studying with the Canadian Space Agency and the European Space Agency this concept of Heracles, and I didn't see that word on any of your charts. What does that mean?
Yeah, it was in the slide, but I removed it because I just had the email saying that we may have to change the plan for that Heracles mission after knowing that Mr. Trump ordered the U.S. to accelerate the process. The Heracles was to be, I think the original plan was like 2020 something, after 2024. And then if that big thing is happening in 2024, it's more productive to change the plan for Heracles. And that meeting is ongoing now. So what I knew is that when I was preparing, after receiving this slide, I got that email saying that there would be we are thinking about changing the plan for Heracles. So that's why I didn't want to show something uncooked, and that's why I removed it from the slide. So it's in the program, but we don't know how we're going to move forward with it. That's where we are now.
Ben.
Hi, Ben Bussey, NASA headquarters. A quick question on your hard lander CubeSat. I didn't see, is it just a demonstration of the hard landing and measuring the Gs, or does it actually have a sensor inside to take some measurements if it survives?
No, it doesn't have any sensor. It's really measuring it's really about how it works, and doesn't have anything to do with the observations.
Okay. One last question.
It's beautiful to see the Toyota fuel cell vehicle.
Yeah, it is.
And
yeah.
I know there are some running around here in the streets here.
In California,
And
yeah.
now, my question is about the 2024 mission, the Artemis mission. Now, does JAXA have any plans relating to that?
Yeah, I've just learned that the high official from funding ministry has been visiting the NASA headquarters this week.
Okay.
So there's serious discussion ongoing, yes. But we are, 2024 is really, really
Close.
for anybody, I guess, and
Yes, it
especially
is.
for us. And yeah, so we'll see what's going to happen. Yeah,
Thank
we
you.
have to see. yeah.
Enjoyed all your presentations. Thank you.
Thank you.
Thank you. Thanks, Masaki. And